In action. Alright, so welcome to a new day of learning in Mrs. Jones' math class. And so before we start, I just want to let you guys know that we're learning something new. It's going to be hard, but you know what? I believe in you. And I believe that, yes, we will encounter challenges, but you know what? I'm there for you. We're going to get through this together, okay? So, let's get started. I need my marker. I don't know where my other one went. So, today we're going to learn, about equivalent expressions. And so our learning target is going to be, can you guys identify equivalent algebraic expressions through simplification? So just keep in mind that we already have skills in our toolbox set, all right? We know how to simplify algebraic expressions, right? With the addition, the subtraction, with the multiplication and division, and we also know about the distributive property. So this lesson is a matter of us putting those skills together to identify equivalent expressions, all right? So I have a warm-up here for you. Oops. What do you know about these two algebraic expressions? We have 6x plus 12 and negative 2x plus 8x plus 12. So I'm going to give you 30 seconds to think about this question. You can turn to a peer, you can jot it down in your notebook, but what do you know about these two expressions? All right, fast forward, right? The 30 seconds has passed by. So when we look at the first expression, we have 6x plus 12. You know, it's already simplified for us. When we look at the second expression, the negative 2x plus the 8x, we notice that those are like terms. We can combine any like terms. So when we combine those like terms, negative 2x plus 8x is 6x. And all we have to do now is bring down that 12. So this expression simplifies to 6x plus 12. Notice that now these two expressions are what? They're the same. They're equal. They're both 6x plus 12. And so here, I'm going to write that they're equal. All right? So, this is the first step of actually identifying these equivalent algebraic expressions. And so, the key word of today's lesson is equivalent expressions. All right? Highlighted for you here. Our algebraic expressions are equal, even though the expressions look different, right? We saw that these two look different. They were still the same. They simplified to the same expression. And so we like to use the equal sign or the not equal sign, which is just an equal sign with a slash, to determine whether they're equivalent or not. All right? So what we're going to do next is go into 3 examples, but we're just going to do the I do, solely me demonstrating to you how to do the process, and then we're going to do we do together. Okay, so we're determining are these expressions equivalent. So when we look at the first problem, so make sure you write down these problems into your notebooks, all right, and follow along. So for the I do, solely just pay attention to what I am doing. So we have the 6 parentheses 3a squared plus 2b, and the other expression, which is 9a parentheses 2a plus 12b. When we look at the first expression, we want to ask ourselves, can we simplify that? The answer is yes, we can, because we know that whenever there's parentheses, we might have to distribute. So we are, in this case, distributing that 6 to the 3a squared and the 2b. So 6 times 3a squared is 18a squared. 6 times 2b is 12b. Simplify completely. Move on to the next expression. Can that be simplified? Yes, we can. These two are being multiplied. 2a plus 9a is 18a squared. Whenever we're multiplying two variables, we just raise it to the next power if they're the same. If they're different, we just rewrite them. And then we bring down that 12b. So we notice that when we simplify these two expressions, they are the same, they are equivalent, all right? So now we're gonna do the we do together, all right? So this looks a bit complicated, but don't be afraid. because, fractions are our friends. We have the negative 10 parentheses 3y plus 1 all over 2 plus 5x. And over here we have 5 parentheses x minus 3y plus 1, right? So let's do this one first because this one looks friendly, right? Because we know that we have to use a distributive property. So we distribute the 5 to the x, the negative 3y, and that 1. So that becomes 5 times x, which is 5x, right? 5 times a negative. Keep in mind, whenever there's a negative, we bring that negative to that term. So that's a negative 3y, which is going to be a negative or minus 15y. 5 times 1 is positive 5. All right? So let's turn our attention back to this expression over here. Keep in mind, we notice that there's a negative 10 and this 2 over here. Excuse me, sorry about that. All right? So whenever we have a quotient, right, whenever we're dividing, if we can divide it, we can always simplify that first. So negative 10 divided by 2 is, we know it's 5. Negative 5, my bad. Rewrite that, write negative 5 over here. So in this case, that means we're distributing the negative 5 to the 3y plus 1. So in that case, we would get negative 15y plus, negative 5, write that in parentheses, plus 5x. All right? So let's look at these two expressions. We have that negative 15y in both, right? We have that 5x, that positive 5x in both, but we have in the first one a negative 5, and in the second one a positive 5. So in that case, these two expressions are not equivalent. Even though they have the same, they have similar terms, they're not equivalent. All right, because they have to be exactly the same. All right, so we use an equal slash. I am so sorry. All right, so you try the you do on your own, okay? So work through that. I'm going to display to you your process. So your answer should be and equals, okay? So what I'm going to do next is I'm going to pass out your practice. So once we have that, we can turn our attention to that as I explain what the practice will be on, okay? All right, so I hope you are looking at your practice for today's lesson. And so what we're going to do first is work on the first portion of the practice, which is our pair practice. And so we're going to be engaging in reciprocal teaching, where you will pair up with another partner. One is going to be partner A, one is going to be partner B. So partner A is responsible for their 3 problems. Partner B is responsible for their 3 problems as well. So one partner would do their first problem. The other partner, partner B, let's say, will watch and provide feedback, guidance, and any support for the other partner as they're working through their problem. Once they're finished with their first problem, the roles are going to switch, and partner B would do their first problem, and partner A is there for support and guidance and coaching. All right, so once you are done with your pair practice, you can move right into your individual practice where you have 3 problems, and it's your time to shine. Just keep that in mind, and as this is all happening, I'll be circulating and giving partners feedback along the way, any guidance that they would need. And if you're doing the individual practice, I will give you more one-on-one feedback so that you can solidify and be masters in these skills, all right? And so hopefully I can get 6 volunteers that want to come up to do the work on the board for these 6 problems. We're going to talk about challenge problems all together at the end of the class, followed by an exit ticket. All right? So if you have any questions, you have me, but you also have your peers as well.